Let's see how much you guys remember about this. Can somebody tell me? Oh, shit. There you go. See what you guys remember. Can you tell me what the slope is? What's the slope between the points? What you got, Jeff? Sure. Can you figure out what the slope is between those points? Well, you shouldn't have to draw a picture, but I mean, I guess you could. I didn't really say you couldn't. Right, because what is slope in words? Graphically, what's slope? Rise over run. It's very physical property. What should the slope of the ground be, of the floor here in this room? The slope should be 0, right? Probably isn't perfectly supposed. It's 0 because I don't rise at all. I just run. So it's 0 over whatever. So it's flat. It's 0 slope. Holy shit, there's a math idea that is perfectly physical. I like it. In fact, have you guys ever, I used to live in Mission Hills, and there's that one insane, and then there's the one going to the airport down Laurel, is it? No, maybe, I can't remember exactly. Crazy steep roads, right? Or if you're driving around the mountains, you'll see 7% grade. You guys ever seen that kind of sign before? 7% grade, 8% grade? They got a picture of a truck, you know, and then they got the runaway truck ramps. I remember the first time I saw that, I was like, excuse me? Okay. All right, now my point with that is, what the shit does 7% grade mean?
It goes down 7 feet for every 100 feet out.
There you go. 7% is 7 per 100. Rise over run. So for every 100 foot you go forward, it's 7 up or down, depending on which way you're going down the street. You with me? Yes, a little bit? All right. All right, I like it. Anyway, okay. So what do you guys get for the slope here? Yeah, because it's y2 minus y1 over x2 minus x1. The beautiful thing, rise over run. Y's rise. Run the other guys. Yay. I'm sorry. So you got 5 minus -1 over 6 minus 4. Okay, nothing major, right? Should be like, oh yeah, Jeff, give me a bunch of those problems. We're not going to do any of those problems, do that. Okay, maybe. By the way, why did he do 5 for? Anybody do it the other way around? Anybody know what the hell these are here for? The little 2s and the 1s? What the hell are they there for? Anybody ever wonder about that? I mean, what does subscripts mean? We have had subscripts in this class. What do they mean? You know, you're the teacher, man. When they came up, you should have told us what the hell they meant. I've got to assume something. What do subscripts mean? They mean this is a specific y value. The y value from what you consider to be the second point. And the y value from what you consider to be the first one. Blah, blah, blah. So a subscript means a specific value of something in some situation or something. It can't be just any value it wants to be. All right, I like it. And the only reason they're really here is because if I do this minus this, I have to do the x's in the same order. Otherwise, my sign is wrong. So, of course, I could have done -1 minus 5 over 4 minus 6. That's -6 over -2, which is still frickin' 3. As long as they do it in the same order, I'm good. Okay. Everybody okay? This should all be kind of a review, hopefully. Now, who can get the equation of this line? How do I know there's a line that goes through these points? Because that's how you define a line. 2 points. You can define a line. Also, a point and a direction defines a line. How the hell do you get the equation of the line that goes through these 2 points?
Isn't there multiple types? Isn't like
there are.
Like
I love it.
Point slope and slope intercept.
Sweet. Oh, look at all this shit flying. Point slope. Sorry, I get so excited about stupid things. Point slope kind of gives it away, right? It's not point break. There's no, sorry. Point slope. It's got the slope in it, and it's got a point in it. There's the point, and there's the slope. Point slope. Because math people are really creative. They're like, it has a point in it, and a slope, and a point slope. All right. And then the other one is slope-intercept. And that's going to be this. Good old mx plus b. That's one most people remember, right? M is the slope, and the theory on that is M in French, to walk is marche, and slope is like walking. So that's where the M came from. Maybe. We don't know. B, I have no idea. Don't come at me. Okay, so this shouldn't be anything taxing, stressful, nothing. You guys remember this formula, anybody? Remember that formula at all? A little bit, some of you guys? I could use that to do this. So what do I need for that equation? I need a slope. We got the slope. And I need a point. Well, I got two freaking points. Pick one. Doesn't matter which one you use. Why is that true? How many points are on any line? How many points are on any given line? Infinite number. So any of them exist on the line, so any of them should give the equation of that line. So it doesn't matter which one you pick. So which one do you want to pick? Second one, okay. So let's do this. Y minus the y piece. What's the y piece? 5 equals the slope times x minus the x piece. All right, now real quick, solve that for y. Put it into the better form, the more concise form. The very first section in chapter 12 is a quick review of lines. So just give me some problems like this in there. All right. What do you guys get? Anybody?
-1.
Yeah, so minus 18, right? 3x minus 18, add 5, minus 13. Careful now, you gotta distribute that bad boy, right? How do you check that? Yeah, what point did we use to create that equation? This one. So let's plug this one in to check it. What's 3 times 4? 12 minus 13. Yay, it does it. It's supposed to be the equation that catches all the points. All the points should work in the equation. Okay, so hopefully this whole thing is very familiar. Or if it's been a while since you took algebra, maybe this part of your brain's going, oh yeah, sounds a little bit. Okay, I like it. So what does this have to do with statistics? I don't know. Oh yeah. I forgot, I should have brought this back to show you again. Remember when I showed you the homework versus average grades? And we had that line that was kind of like the graphical average of all the points. I love it. So that's, and I said at the time, we're going to know how to get the equation of that line and to get an idea of how strong that fit is. So let's start there. In fact, let me give you this handout. We can all talk about it. Yeah. Okay, let's take a look here. Okay, let's see. This, by the way, just to let you know, back in 2005, it's 2004, when I applied for this job, I had to videotape a lecture and send it as part of the application process. This was the lesson I videotaped, and they said they liked the fact that maybe I was a beer drinker. Yes. Oh, what happened? I thought I gave plenty enough. Okay. What about this? So, this is not a suggestion as for an experiment to run, so let me just get that little announcement out of the way. But, I'm sure some of you guys have lived this before. Maybe even recently. I lived this a few times. But, this is the idea of if you go out drinking the night before, a very early test. The number of beers you drink might have some kind of an effect on how well you do. In fact, anything that causes a shift in how you feel might affect your grade, right? Both of these have what kind of a trend? Yeah, down, negative, a negative trend. Right? Meaning, as the number of beers increases, it seems that the grades also, or I'm sorry, increases, it seems that the grades decrease, right? Now, which one of these has a stronger relationship between the two variables? Second one has a stronger relationship. Which one is more realistic? Say again? Yeah, the first one's more realistic. Who is this person right there? Did they drink much? Comparatively? No. And how well did they do? Not. So that's somebody who doesn't know anything. So it don't matter how many beers they maybe they drank some more, they would have done a little better. I don't know. And who's that person there? You didn't drink. Yeah, because they're able to hold the beer. Maybe not alcoholic, maybe. But they're able to handle their beer. Maybe they don't get a hangover, which would be great. And so they also did very well on the test. So they actually knew their shit, and they didn't drink so much that it caused them to not be able to do it. Are you guys kind of with me? And those two, of course, would be examples of outliers. You guys. I like it. But if I needed to, can you guys try to draw a line that would represent the graphical average in that first one? The second one would be easy. It almost makes a line already. What would the line be for this guy? Maybe even ignore the outliers, because do you see if I say this, don't the outliers kind of cancel themselves out? So if you drew a line to represent the trend, to represent the graphical average of all the points, can you try to draw that line? And then I'll try to draw it, and we'll see how close we get. All right, I like it. So something like that, right? You could even use a straight edge, make it straight. You might want to do that later. I want to give you a little handout. We're going to do this a little more technically. What that line does is, like I said, it's a graphical average. It kicks so much ass. In fact, here's what's kind of funny about what we're going to do today. What did I say? Every time we got a new distribution of data, what two things did we need to be able to figure out? The mean and the standard deviation. That's the mean, in a way. The line is called the line of best fit. That is the official name of it. And that's such a cool name. It best fits the data, and it's a line. So this is the line of best fit. And the other thing we're going to learn is how to calculate what's called the R value, which is sort of a two-dimensional standard deviation. I'm going to show you the formula that we're not going to use. I just want to show it to you. And it is about how far, the best line I could draw would do what with the point's distance away from the line. If I drew the best line I could draw, what would be true about the distance from the line to all the points? Compared to like a worse line, right? No? I see what you're saying, but they would be minimum. Do you guys see what I'm saying? So the line of best fit is the only line that gets closest to all of the data points at once. So it's also called the least squares line. Because if you square the distances, it makes the sum of those as small as possible. All right, maybe. Just want to get a little more technical for a minute, and then we can come away from that. So that's the line of best fit. So this guy, the line would be really easy to draw because, like I said, the points almost define a line. This is a stronger relationship. What about here? Which one has a stronger relationship, obviously? First one? Which one's more realistic? Second one? What would you say about this person? Well, look. They studied like the second most, didn't they? But they aren't doing well, right? This is the grades. So do they have a very high grade? Do they have a very high grade? No. But did they supposedly study a lot? Yes. And see, I've said the magic word. Some people don't know what study means. So maybe they did a lot of time, but not much of it was actually studied. Maybe. That's just one possible explanation. So that's one outlier. Who's this person? Yeah, exactly. Okay, I like it. So you're already interpreting it. So that person is somebody who didn't study much, but is doing relatively well. It's about the fourth, fifth highest grade, right? So that maybe they already took a class, or maybe they're just one of those people, right? Now, everybody, you hit a class. Have you ever experienced a subject where you didn't really have to do much and you just got it? Has everybody done that? You could probably guess mine. I know. All right, it wasn't painting class. So maybe that's the one. This class is the one that this guy didn't have to open the book much, don't have to study much, and they just get it. Okay, how we do? Maybe. So this interpretation of these outliers is a part of what you might do with a study. It's not something that we're necessarily going to have to worry too much about directly. I just want to point this out. And if I drew the line of best fit here, it's a little bit better than that first one, I think. But obviously, see now what's wrong with that line I just drew? It should be what? Does that line look okay? What should happen to it? It should have to. So should I just move it up or down, or should I rotate it up or down? Do you guys see what I'm saying right now? Can you see, did I put the line in the right place? Not quite. Can you guys see that? So what is it that tells me that's true? Well, look at the points above versus the points below. There's more points and more of them get further away. So shouldn't the line at least be up a little bit, or maybe even better, rotated a bit? I'm kind of glad that just happened. I didn't do it on purpose, to be honest. I drew a sucky line, but too bad. Anytime, and I'm about to do this to you, give you a handout with points, and you have to draw the best fit line. You almost always have to do it at least twice. Because you draw it once, you realize where you went wrong, and then you do it again. Maybe. So just remember that in a minute, or a few minutes. Okay. So we need to have a way to figure out the line of best fit equation, which is what this is all about, and also to figure out the value of this R, which is why I was trying to get you guys to make an actual sigma instead of an R, because R is something else entirely. It's the Pearson product, or the correlation coefficient. There you go. A value of -1 means perfect negative correlation. So which graph is closest to R equal -1?
Right?
Yeah. This is closest to R equal -1. If I had to make a guess, I'd say that's R equal -0.9 or something. So -1 means you line up perfectly in a negative slope line. So as one decreases or increases, the other one decreases lockstep. If I pull some of the points away from that line, I'm going to make R go away from -1. What would R equal +1 mean? If R equal -1 means perfect negative correlation, R equals +1 means perfect positive correlation, which means all the points are directly on the line. They define the line. None of them are away from the line. You guys with me? And again, if I pull them apart, it goes to 0.9, 0.8, 0.7. So what should 0 mean? No. 0.9 means not perfect. 0.99 means not perfect. It just means strong. What should 0 mean? No correlation. No linear correlation. How are we doing there? So watch this. R equal to paper. So R equal to -1 would be something like this. Let me draw a line first. There we go. Well, all the points are perfectly on the line. In nature, that basically never happens. If you plotted, so R equals 1 would just be something like this. All the data points are perfectly on a positive slope line. So if I plotted the length of a fish after it was born, or the height of a human after they're born, shouldn't I expect the height? Now, obviously, it doesn't go perfectly linearly, but it should be pretty close to that for a while. And thankfully, it does this, or else, we got a bunch of freaking 50-foot tall people roaming the earth. Attack of the Titans. Hopefully not. Yes, no, maybe so. Maybe. But so in nature, it's never going to be 1 because you're always going to have differences in how you grow. Maybe you had some coffee when you were 2 years old. So maybe it's not the best idea in the world. So, and R equals 0 could be something like this. Here's the basics. That could be R equals 0. There's just no frickin' trend anywhere. It's just all over the place. Or, here's a surprise. Here's R equals 0 also. Why is that R equals 0? It makes a line. As X increases, what does Y do? It doesn't do a damn thing. It doesn't give a shit. So if I were to jump, and then I measure how tall that tree is, and I'm like, all right, let me jump higher. Okay, jump. See how tall the tree is. All right, let me plot that. Let me jump higher. Now see how. Do you see? That's dumb. It's remarkably dumb. I don't care. So is this guy. These two just don't care about each other. So of course R would be 0 here. And alternatively, if it was straight up and down. Okay, maybe. So be careful. R equals 0 doesn't mean there's no line. It just means there's no correlation between them. One's changing doesn't seem to also have the other one changing at the same time. Okay, maybe.
So that would mean your X and Y axis have independent variables if one doesn't have any effect on
They would be independent from each other, yeah. And we need some kind of dependence for this correlation to exist. I like it. The other thing to be careful about, I'm trying to be careful with how I say this. And some of you guys might have heard this before, but correlation does not imply causation. So even in something like this, with study time, I think I addressed this when I showed you the homework versus grade earlier this semester. Does this necessarily mean that if somebody is here and they study more, they're going to move up? No, it doesn't mean that. It doesn't mean that at all. You can't say that for certain. Now, it does make sense that should probably happen, but the study itself doesn't say that. So here's a true fact. Teachers' pay goes up. If teachers' pay goes up, the liquor sales also go up. Does that mean that teachers are a bunch of booze hounds that, we just need some money and then we're on it? Or what is that? Is there some third thing behind the scenes? Well, if teachers' pay went up, probably other people's pay went up. And if the general populace's pay goes up, probably everything was sold a little more. Do you guys see what I'm saying? So you can't say, there's so many reasons why you can't say, I see a correlation, therefore this will change that. You don't know. There could be something behind the scenes. So this is a surface level first step analysis to do. And then you can go deeper into creating an experiment to show a cause between two things. Okay, maybe. So for example, here's really another dumb thing. Say I'm watching some basketball games and I write down, playing basketball makes you taller. Intriguing, right? And that's really, really, really stupid, right? We know that's obviously not true. In that case, being taller makes it more likely possibly that you might play basketball, right? Even though I played basketball for a while. Anyway, I'm going to talk about that before. So, when you hear about two things are correlated, this happens more often than you might think. People try to then just start talking about as if I change this, that's going to change this. You don't know. If you do a correlation study, you have no idea if changing one will change the other one. All right, maybe. So correlation does not mean causation. So when I ask you a question like, all right, if a kid studied more hours or if a kid drank more beers, does that mean their grade will definitely change? No, you don't know. You can't say. Okay, maybe. All right, I think I said everything down. So let's do this. What I've tried to do on the back is several things. Does this first piece look familiar to anybody? Anybody? There's this thing on the website that I've referenced a few times. It's called the Calculator Guide. I used to call it the Calculator Bible. And this is on there. It tells you how to do everything in your calculator that you need to do for the whole semester. It's been sitting on there since before day one. So I decided, since not very many people seem to do anything with that, I put this here for you. And this is how you do these kind of problems. Oh, and before we do this, so let me do this. Do you guys see this here, the beers and grade? Go ahead and start putting this into L1 and L2. Do you think you should should you sort these? Because 0.5 has to go with 98. Each row is a person, so you don't want to sort them. I like it. Yes? Oh. Anybody else need a calculator? There it is. I love it. Okay. Oh, you need a handout?
No.
Okay.
Handout.
Handout. And just what I normally do as I'm, like for example, right here, as I'm entering this data, I'm going to make sure that I'm going to stop and then, okay, does 90 go with 2.3? Yes. Because what really sucks is you get to the bottom of list 2 and it's not the same size as list 1. Okay. Okay, I got it. So I think that should be right, hopefully, we'll find out. Alright, so pretty good. So let's do a few things. I'm going to say this again in a minute, but everything we're about to do, you're going to have to do on something that's graded and come up and show it to me. So we're going to recreate the scatter plot, the points on the calculator. Then we're going to calculate the line of best fit in the R, and then we're going to make the calculator graph the line of best fit. Everybody with me? A little bit? And then you're going to have to come up and show me your scatter plot with the line of best fit on it to get points for doing that. I like it. Okay. If I just want to plot the points, I want to plot my statistical data. You guys see where I should go? Stat plot, right? I wish you could just push these. So go to stat plot. If you have your own calculator, you can just leave it set up with what we set up today, and then you're good to go. If you don't have your own calculator, you borrow one, I can set it up for you real quick before the test starts or whatever. So first thing I want to do is, let's go ahead, everybody hit number 4, enter. Just to really make sure we start off with nothing on. Plots off, done. All right, let's go back in. Second y equals to get back into stat plot. Let's all turn on plot number 1. You don't have to know plot 1 psychology. We just hit on, bam. Make sure, now, I can't remember if we got in here before, but look at all the evil nature of myself that I never mentioned to you that could do all these things. Oh, I'm so evil. But too bad. You can make histograms and box plots. Make sure it's got the scatter plot. See the first one with the points? Make sure that's highlighted. Just go on to it and hit enter. Make sure you got L1 is my X's, L2 is my Y's. I like it. Everybody with me? Let me know the minute you're not with me in this. Oh. Oh, hit enter. There we go. Turn that on. Highlight the first two, the one with the points. Right? Yes.
This one doesn't come out with the line.
Oh, you have to highlight the points. Yeah. Type wants to be scatter plot with the points. Yeah. Enter. Bam. Look at that. All right. How's everybody else? You guys all right? Technology day is always nerve-wracking. Okay. Then you get to pick which mark to put on every data point. I am obviously a square. I'm going to keep it there. You could be positive. You could be a big speck of dust or a small speck of dust in the universe. That's just going to be what it puts on every data point.